So back again, and this time we have here we have a nice trigonometric identity to prove. Here you can see that sine 2 theta plus sine 4 theta plus sine 6 theta plus sine 8 theta blah blah blah, and the denominator has almost the same value, but the function is cosine, and we have to prove that it is actually equals to tan 5 theta, tangent 5 theta. So how we are going to prove it? Let's see. To prove, we can take left hand side, and obviously we will be taking left hand side because it has quite a lot of terms. So in the left hand side we can have this whole. So I have just copied and pasted over here. The I is actually missing. Yeah, we got I also. Now for this we know that we have some trigonometric identities like sine u plus sine v, which is actually equals to 2 times sine u plus v over 2 cosine u minus v over 2. So we can apply this identity over here in these two terms. Yeah, we can separate these terms, and for the denominator we can write cosine u plus cosine v is equals to 2 times cosine u plus v over 2 times cosine u minus v over 2. Great. So for these two terms we have u equals to 2 theta and v is equals to 4 theta. So just simply apply this identity. We will be first writing 2 and sine u plus v, so it will be sine 2 theta plus 4 theta divided by 2 and cosine 2 theta minus 4 theta divided by 2. These two terms are in place of this. Now for these two terms
we can write plus 2 times sine u plus v, so we can write 6 theta plus 8 theta divided by 2 and cosine 6 theta minus 8 theta divided by 2. And for the denominator, I guess you guys have got the idea, so let me just quickly write it for you.
So now as you can see over here, we can take 2, or we can factor out 2 in the numerator and factor out 2 from the denominator. These 2 will be cancelled out, so we will be left with sine cosine plus sine cosine, and in the denominator cosine times cosine, cosine times cosine. So for the sake of simplicity, let me just solve this in over here, which will be 2 theta plus 4 theta, it will be 6 theta, and 6 divided by 2, so it will be just 3. So we'll write sine 3 theta, and over here we have cos 2 minus 4, it will be minus 2, and minus 2 divided by 2, so it will be cosine, but the angle will be negative. I've written 8, yeah, so it will be negative theta, plus sine 6 plus 8, it will be 14, and 14 divided by 2, so it will be 7 theta, and cosine negative theta divided by cosine 3 theta and cosine negative theta plus cosine 7 theta and cosine negative theta. Let me just make some space. Yeah. Now as you can see here, in the numerator we can take cosine negative of theta and factor it out, and same in the denominator, so it will be cancelled out, so we will be just left with sine 3 theta plus sine 7 theta in the numerator, and in the denominator we have cosine 3 theta plus cosine 7 theta. Now again applying the same identity we have just applied in the very first step, which was sine u plus sine v. So applying this in the numerator, we will have 2 times sine u plus v, which means 3 theta plus 7 theta, which will be 10, and 10 divided by 2, so it will be just 5 theta, so I am just writing it 5 theta. And cosine 3 theta minus 7 theta, so it will be negative 4 theta divided by 2, so it will be negative 2 theta. In the denominator it will be 2, and cosine, we have cosine over here, so we will apply the identity of cosine. So it says that 2 times cos u plus v over 2, so it will be 3 theta plus 7 theta over 2, so it will be 5 theta, and times negative of 2 theta, cancelling out these 2, so also this 2, so we will left with sine 5 theta divided by cosine 5 theta, cosine 5 theta, and we know that sine over cosine is equals to tan theta, so it will be sine 5 over cos 5, so it will be tan 5 theta, which was the actual proof. So if you like my video, give it a thumbs up, and I'll see you next time.